Kilauea Lavafall. What you are looking at is an aerial view of the 50-meter or 164-foot-high lavafall still cascading into Kilauea's Napao crater. This is still ongoing on day 5 of Kilauea's ongoing flank eruption in its Middle East rift zone, even creating a rainbow at one point, although the rate of lava effusion does appear to have decreased in the last 24 hours. So much molten rock has poured over the edge of its crater rim, in fact, that its slope has transitioned from what was likely around 85 degrees to around 75 degrees, as you can see in this USGS photograph. Yet, while a 50-meter high lavafall is still pretty cool to witness if you want my totally unbiased opinion, it still does not compare to past lava falls which formed in the East Rift Zone. For example, on August 5, 1969, an early pulse of the Mauna Ulu eruption resulted in lava cascading down the now completely filled Inalei pit crater, resulting in 165-meter or 541-foot-high lava falls, involving an eruptive rate 13 times higher than the current eruption. Back to the ongoing eruption, lava has continued lava field expansion to rapidly cover slightly more than two-thirds of the Napao pit crater, almost entirely covering its southern third during the last 24 hours. Molten rock is still flowing in this direction as it marks the lowest topographic point on the crater floor, specifically being fed by a variable rate of lava effusion of between 5 and 15 cubic meters per second. This is a fairly low figure, almost identical to the long-term average eruptive rate of Iceland's Fagradalsfjall volcano during 2021. Regardless, when combining all lava flows which have erupted this week, Kilauea's latest flank eruption has now covered a total of 0.559 square kilometers or 138.24 acres. All of this has been emplaced in a remote region far away from structures, with 86% of the total lava erupted so far ending up on the floor of Napao crater. This begs the question, why does Napao crater exist pit craters in the first place? While it might initially look like a small caldera or a Mar explosion crater, it is in fact neither of these, instead being best classified as a pit crater. Pit craters are not formed by volcanic explosions but rather, much like sinkholes, by the ground collapsing underneath them due to cavities forming. In this case, the cavity was likely related to the draining of an ancient pocket of magma, of which there are many in Kilauea's East Rift Zone. This pocket of air then migrated upwards over time, until reaching the surface sometime between the year 1250 and 1600. We can thus assume that the body of magma that once underlaid Napao crater by more than a mile was approximately the same width as the modern crater, and that it was once much deeper, having been largely infilled by younger lava flows. Napao crater is likely destined to be completely filled by young lava flows, although probably not from the current eruption. Some people have speculated that the 4 pulses of activity which have occurred so far in Kilauea's latest East Rift Zone eruption are similar to precursor eruptions that happened before large lava shields such as Pu'uo or Mauna Ulu were constructed. I must disagree with this assertion, as those eruptions involved both much longer fissures and an eruptive rate at least 10 to 50 times higher. Instead, assuming the remaining fissure stays put, I merely expect one or more small spatter cones to be constructed, basing this partially off of similar features you can find nearby. Lava shields have formed only 4 times during the last 1,000 years of Kilauea's lava shields East Rift Zone. They represent central dominant vents in multi-year long eruptions which rise more than 50 meters above the surrounding landscape, and cover more than 40 square kilometers with at least 250 million cubic meters of lava. As a final note, I would like to thank this channel's patrons on Patreon and channel members on YouTube.